Hello, everyone. This is Mike Steckline, partner for Institute for Enterprise Excellence. We're having a presentation today from Dan Roberson. He lives in near Lancaster, Pennsylvania, and the topic of his presentation is shown on your screen: A3 thinking, the biases and heuristics of problem solving. And Dan agreed to put this together back in August, and we had one attempt and we had some challenges. I guess we were working through some problem solving. We were doing some problem solving before today's webinar. So we're hoping that with some confidence, we're going to be able to present this for you. A little background and housekeeping and ground rules. I do have the phones muted, but we've got some time toward the end for some Q&A. You can use the chat function to type in a question at any time, and we'll be able to give that to Dan, and he can talk through with that. And this webinar is being recorded and is available for those that participate, as well as others that weren't able to participate today but would like to benefit from it. And you can also forward that link on to others that'll be available after the presentation. When I think about some of the work that Dan and I have been talking about, and I think about the model that we use, this is our model for sustainability, some things that I think Dan is going to be touching on. We talk about guiding principles. I think one of those guiding principles is going to be embrace scientific thinking. We talk about important systems that people try to build and maintain, and I think he's certainly going to be talking about a problem-solving system. And I'm sure that he's also going to be talking about some of the tools and methods that he uses for problem solving. So I'm going to change the presenter over to Dan, and then he's going to walk us through his slides. And again, thanks to Dan for putting this together, and we'll look forward to learning from him. And again, if you've got any questions, feel free to use the chat function, and then we'll unmute a little bit later. Take it away, Dan.
Excellent. Just want to make sure everybody can see a slide that says purpose is the title. Mike, you can see that?
I do. I see it.
Excellent. So my name is Dan Roberson. I am a performance improvement coach at Penn Medicine Lancaster General Health. And for the last about 10 years or so, I've been practicing problem solving, specifically A3 thinking in healthcare. And in the last couple of months, I started to have some conversations about some biases that seem to be common when teams try to solve problems. So that led to some other conversations, ultimately about some general problem solving strategies, also known as heuristics, which I'll actually define on a slide in a few minutes. But the purpose of today's talk is to try to highlight some of the commonly experienced biases. Specifically, when teams are trying to learn how to solve problems, what ends up happening is when you run into the biases, that can actually prevent good learning. And this is all part of an improvement system, like Mike was talking about. And I really like the definition or the quote at the bottom of this slide from Stephen Spear in his book, The High Velocity Edge. And in fact, I paraphrase it saying that complex systems cannot be designed, they have to be discovered. And I like it a lot because this is essentially helping us discover how to practice a complicated or complex improvement process that we sometimes call A3 thinking. So I'll elaborate on that a little bit more as we move through it. But my hypothesis is, and the expected outcome of today, is that an awareness of some of these common pitfalls will actually lead to changed behaviors when we practice problem solving, which will then lead to better problem solving. So this slide, I just have a snip of a few of the covers of 7 books or 8 books that I've actually used as references for the presentation. On the last slide for today, I actually have a reference list, so you'll be able to take at some of the titles. But a few of these I just want to point out that I think have been very largely inspirational to today's talk. One of them is the Thinking Fast and Slow by Daniel Kahneman. Kahneman and the book, The Psychology of Judgment and Decision Making by Scott Plous. These 2 books were really, in large part, inspired me to try to understand the psychological side of improvement work. In addition to that, The High Velocity Edge by Stephen Spear. I've used his paper with his that he co-authored, Decoding the DNA of the Toyota Production System, as a reference for a number of years. And in The High Velocity Edge, he expounded upon some of those ideas quite a bit. And they've been very inspirational in terms of trying to practice problem solving. And then Steven Pinker's Sense of Style is actually a book that has very little to do with improvement work, but is, as the subtitle states, the thinking person's guide to writing in the 21st century. And Pinker is a psychologist at Harvard, and in his book, he writes partially about a topic known as the curse of knowledge, which I'll elaborate on in just a moment. Some of the other books that are listed there have been really important, and specifically Deming's The New Economics, which leads me to a statement around the system of profound knowledge. And as Deming says, in The New Economics, the prevailing style of management must undergo a transformation. A system cannot understand itself. The transformation requires a view from outside. And the aim of the system of profound knowledge is to provide a lens that provides a map of theory by which to understand the organizations that we work in. I think the system of profound knowledge is going to be one of the most influential points for my talk today. And as I try to practice applying the system of profound knowledge, I think it's really important that we have a foundation of what it is so that we don't practice components of the system, but that we practice it as a system itself. And that brings me to defining the system of profound knowledge. So one point is having an appreciation for a system. In fact, a few months ago, Mike Steckline gave a nice talk about the Cynefin framework and complex adaptive systems, which if you've not looked at that webinar, it's available on YouTube also. Mark Graben gave a talk about understanding variation and his upcoming book, Measures of Success. I want to talk a little bit today about the theory of knowledge, or theory of learning, and psychology. And the theory of learning, where we'll have rapid learning cycles, but specifically psychology and the interactions between people and how those people interact in a system of management. Scott Plous's book, The Psychology of Judgment and Decision Making, actually has, it's a really great overview of a lot of research over the years in social psychology. And in the center of this slide, I have a quote from Matthew May, who's written The Elegant Solution in Winning the Brain Game. And I find that when he says what appears to be the problem isn't, what appears to be the solution isn't, and what appears to be impossible isn't, this is very inspirational in terms of how we learn how to practice the process of process improvement. And now, just so that I don't suffer from the curse of knowledge, I want to define heuristics and biases. And heuristics are just rules of thumb or general problem solving strategies. We actually use heuristics all the time. And biases are deviations from normatively derived answers or errors in prediction or estimation. I'll talk about some biases and heuristics together as we walk through the rest of the talk, but the rest of the presentation will get us into some of the details. And I mentioned from Steven Pinker, The Curse of Knowledge, and it's not just Steven Pinker who writes about the curse of knowledge, but the Heath brothers, who wrote an excellent book called Made to Stick, and actually have an awesome Harvard Business Review article where you can see the link, so you can either click on that or type it in to check out the tappers and listeners activity. But the curse of knowledge is the idea that when you know something, it's almost impossible to remember what it's like not to know. And because of that, it's really difficult to explain that thing to somebody who doesn't already know it. Now, I actually teach at a local college, the Graham School of Business at York College of Pennsylvania, where I'm an adjunct instructor in the business department. And I typically teach business statistics. And I bring this up now because when I talk about the curse of knowledge, I can't help but think about when students are in a statistics classroom. Because when a student goes to a statistics classroom, very commonly, it's not the topic or subject they are most interested in. So we're already at a disadvantage for learning opportunities because the learner is not always engaged and ready to learn. And then to make it worse, what happens a lot is statistics professors succumb to the curse of knowledge. They forget what it's like not to know what standard deviation is. And because of that, they talk about standard deviation as if everybody already knows what it is. And they simply show an equation and they show how to calculate it. And they say it's a measure of variation that's in the same units as the mean. Does everybody got it? Any questions? And we move on. And when we do that, people don't ask questions commonly because they're afraid of looking silly. And I think it's in large part the instructor's responsibility to acknowledge the curse of knowledge and try to ensure that the message that is intended is actually the message that's received. So using concepts such as teach back or guided practice to ensure that there is demonstrated competence as opposed to simply going over material and then moving on. So I bring up the curse of knowledge because even though it's not a specific heuristic or bias, it is something that prevents learning from occurring regularly. And I would be remiss not to bring it up specifically today when we're talking about learning. And I also can't get away with not using a Dilbert. So here, pointy-haired boss shows up and says, Carol, schedule a staff meeting. And Carol says, what's the topic? Well, I planned a few Six Sigma lean methods to eliminate the gap between our strategy and our objectives. And Carol says, well, I'll just say wasted time. And I have this here because this is really a problem with problem solving. We try to teach problem solving. We're not always aware that some of the deviations from the lesson are not because people like to be difficult, but because of some of these unconscious biases that are often rooted in success in the past. So I'll elaborate on that in just a moment. But that brings me to applying A3 thinking to solve problems. And A3 thinking, I'm not going to go into a lot of detail about A3 thinking, but I do want to provide a few comments about what it is so that there is context for applying the biases and heuristics concepts to problem solving. So A3 thinking from Managing to Learn, an excellent book by John Shook. It's a management process to solve problems, and specifically the fourth bullet on this slide, it helps keep teams from jumping to solutions. One of the traps of traditional thinking is that teams jump to solutions. We think we know what the problem is before we truly do. We think we know what needs to be done before we've even considered the cause and effect relationship between the symptom of the problem we've identified and its actual cause. And the bottom line is when teams instinctively and very commonly seek to add complexity to problems in an attempt to solve them in the form of adding space, staff, or stuff as a first course of action, it's very dangerous and it's not sustainable to do that. A3 thinking is a very powerful way to prevent teams from succumbing to that trap of traditional thinking. It's rooted in PDCA. In fact, I often just describe A3 thinking as best practice PDCA, and PDCA is simply the scientific method applied to process. And I've yet to meet anybody who can argue against using the scientific method to solve a problem. So Plan, Do, Check, Act, or PDCA, sometimes we also refer to it as PDSA. But the bottom line here is that when we find root causes of a problem, we can run experiments. And experiments are different from the trial and error that commonly happens when teams attempt to solve problems, because experiments have an expected outcome or a prediction. So what we should be doing when we're trying to solve problems is determine a root cause or a hypothesized root cause for which we develop a specific hypothesis that says if we make a specific change, then we'll produce a specific benefit as measured by a specific result. When we do the experiment to test the countermeasures, that enables us to check to see if our prediction was accurate or not, because maybe it was wrong, not because something didn't work, but simply because we were bad at making predictions. So we can compare the actual results to the expected results and then understand why there's a gap, understand why there was a difference between expected and actual, and then make a decision how to make forward based on what we learned through that rapid learning cycle. So PDCA is really the root of A3 thinking, and I'm showing here an example of the A3 template that we use in our organization at Penn Medicine Lancaster General Health. We actually split our template into quadrants, where the upper left quadrant, we kind of call this very creatively quadrant 1. This is why this problem and why now. And I'll elaborate a little bit more about that in just a moment with an animated slide. The second quadrant, the lower left, is the Missouri quadrant, or the show me quadrant, because we want to understand the current process and make it visible. The upper right quadrant, quadrant 3, is show me something better. If we could resolve the root causes of the waste or variation we identified in quadrant 2, what would the process look like now? And then the fourth quadrant in the lower right is about action and learning. It is about what do we learn when we discover the differences between what we expect to happen and what actually happens. And I like this because when I use the template, I always draw the problem-solving funnel. And the problem-solving funnel is helpful to understand and break down a problem so that teams can focus on rapid learning cycles rather than trying to solve a big problem with one big solution, solving the problem in one fell swoop, which almost never results in sustainable improvement. So what you can see at the top of this slide is a vague problem in a cloud. This is the thing that's experienced. This is the thing that the team feels. And it's important, but it's not complete in a way that allows the team to solve the problem. So what I mean by that is a starting point, enabling us to understand it better. And the first step to do that is to measure the problem. And we'll use a number or a percentage or something that on the A3 template, we refer to this as a problem statement. It helps us to frame the problem in order to answer what I consider the most important question with problem solving. How will we know if we're better or not? After we make a change, how do we know the difference between a change that we've made and an improvement? And this is critical because I've met very few teams who suffer from improvement fatigue, whereas I've met many teams who suffer from change fatigue. And part of that is because we don't have the discipline to tell the difference. And I'll elaborate on framing the problem in a few minutes with one of the biases that we have. Next, though, in the A3 template, specifically with the funnel, is what we refer to as the background section. And this consists of 2 charts in my interpretation. One of those charts is to help us clarify the problem. And what I mean by that is we want to look at that number or percentage that we used in the problem statement. And we want to look at it over time so that we can see our current level of performance relative to a target. Because when we can see that performance gap, that helps us better understand what we mean by stating the problem. And when we see the performance gap, it enables us to do the second part of the background section. And the second part is to break down the problem into chunks. And those chunks come in the form of using a Pareto chart to separate the critical few contributors to the problem from the trivial many. And I'll just use some generic notation because thing A, thing B, and thing C contribute to the performance gap. Because what I want teams to do is what I love about this part of the A3 in the funnel is you can see that the picture of the funnel in the background is actually, we're starting to narrow our focus, specifically narrowing our focus onto thing A being the largest contributing factor to the performance gap, suggesting that if we can eliminate the root causes of thing A, we can get better by the amount that thing A contributes to the performance gap. And by identifying thing A, we can ask ourselves, well, what is the current condition? What is the process that we follow right now that leads to the thing A being the largest contributing factor to the performance gap? Because when we see this current condition, when we map it out using a process flow chart or a pathway diagram or whatever format makes sense to the team, we'll start to see that, hey, there's a decision point. We've got variation in the process, or we've got unnecessary steps that contribute to the process, or hey, look, we roll back, we loop back on ourselves and end up having to do some rework. Because when we see the current condition, that brings us to the narrow part, the nozzle of the funnel, where we can ask why the waste and variation is present. And when we ask why at a deeper and deeper level, it gets us down to an actionable root cause. And that actionable root cause can actually, it can be addressed. We can develop an action plan or a countermeasure to help us resolve that root cause. Now, I take the funnel and I actually just apply it to the A3 template that I showed you earlier. The problem statement, the number or the percentage that helps us to answer the question, how will we know if we're better or not? The background section, a series of 2 charts helping us see the performance performance gap and identify the largest contributing factor to that gap. The current condition helping us see the waste and variation that's part of the process as it exists today, and the problem analysis getting us down to an actionable root cause. Because it's from this actionable root cause that now we move to quadrant 3, because it is up in the ideal condition that now we redesign the work to perfectly resolve the root causes of the waste and variation from the current condition. And that ideal condition is probably a simpler process, a more elegant process. And it's possible, though, that that process is not something that we can implement today. So we may have to be inspired by that ideal and create a target condition. The target condition is going to be closer to the ideal condition than the current condition, and we will develop a specific hypothesis, an if-then statement. If we make specific changes, then we'll get specific benefits as measured by specific results. And then we simply follow one experiment flow to test the hypothesis, to make the target condition a reality, which is inspired by that ideal condition that perfectly resolves the root causes of the waste and variation current condition of the largest contributing factor to the performance gap. So this is all I really wanted to get into about the A3 template, because it is with the A3 template that we practice problem solving. And when we practice problem solving, we actually, this is where we run into some of the issues that I'm referring to as biases, and we succumb to the effects of some of the heuristics. Now, as I move forward, I'm actually going to have 3 brief interludes, and I'm posing a question, but I'm not asking anyone to respond to this. I'm asking you to think about how you would answer. And in fact, I even encourage you to write down your answer, not because we'll come back to it later, but because we sometimes change our answer without realizing it when we have a bit of a discussion. So please don't feel obligated to try to answer, but do consider the answer to this question, which is a more likely cause of death in the United States, being killed by falling airplane parts or being attacked by a shark. I bring this up because it allows me to introduce a concept known as the availability heuristic. Most people, when posed with the question, what's a more likely cause of death in the United States, being killed by falling airplane parts or being attacked by a shark, most people respond with a shark attack. And when people respond with a shark attack, they are succumbing to the effect of the availability heuristic, which is when we estimate the frequency or probability by the ease with which instances come to mind. But it's interesting because it is 30 times more likely to be killed in the United States by falling airplane parts, based on a study in 1990, which actually I got from Scott Klaus's book, The Psychology of Judgment Decision Making. 30 times more likely to be killed by a falling airplane part than a shark attack. But it is much easier to think about the last time you heard of a shark attack. It comes to mind much easier that you've seen the movie Jaws, or you've heard about a shark attack over the summer season. And because it's easy to recall a shark attack, it seems like it's more likely to happen. This is also true when teams try to solve problems. Teams say things like, well, this problem happens all the time. Or they say things like, well, I don't have any data, but anecdotally, this is how it happened. The reason why it's so important that teams measure the problem is because of the availability heuristic. When a team says this problem happens all the time, that is a surefire signal that it happened once, and it happened one time that was very painful. And when that's the case, it seems like it must happen more often than it really does, because of the availability heuristic. So we have to answer that question: how will we know if we're better or not? Many teams say things like the natural way to solve problems is, well, we don't really have time to measure, we just need to make this change. And that's an indication, that's a trigger for us to respond by framing the problem with a problem statement, beginning to break down the problem. Because as I have listed on the slide, an axiom of problem solving is that all improvement is change, but not all change is improvement. This is why we must have the discipline to tell the difference between changes and improvements. So in the chart below, at the bottom of the slide, you can see in our current, if you see that our current condition, or in this case, our current performance gap shows that we have an opportunity to improve. And in the chart, you can see that we have 50% of the problem is attributed to thing A, 30% to thing B, and 20% to thing C. It is here now that if we say 50% of the problem is attributed to thing A, if we could perfectly eliminate the root causes of thing A, then what our hypothesis would be is that we would get 50% better. We're answering the question, how will we know if we're better or not? By measuring the problem. And it's very difficult to make an informed prediction about better when we don't have data to break down the problem. So my suggestion is we practice the process of process improvement, starting with a problem statement to make sure we can tell the difference between making changes and making improvements. Bringing me to my second interlude. So I want you to think about a time that you were driving down the road and a car flew by you on the highway. And I want you to imagine what your reaction is when this type of thing happens. Because it brings me to another quote, this time from George Carlin. Have you ever noticed that anybody driving slower than you is an idiot and anyone going faster than you is a maniac? I think this is interesting because most folks, when I ask this question, they say, yeah, I can think of a time when somebody drove by me and I was like, boy, they're what an idiot. They're flying down the road. It's unsafe. It's a mistake. And I think that's a normal reaction, and I'll explain why in just a moment. But I'd like to introduce another example from Dilbert, where Wally walks up to the pointy-haired boss and says, sorry, I'm late. I had a car problem. Pointy-haired boss says, what kind of car problem? Wally says, I didn't get in it soon enough. Pointy-haired boss says, that sounds more like a you problem. And Wally responds with, then my stupid car took me to Starbucks. So here's another example of blaming the person instead of the process. So this is an example of the fundamental attribution error. And the fundamental attribution error is the over-readiness to explain behavior in terms of dispositional factors, also known as personal tendencies, that are often patently incorrect. And it's a pervasive tendency for an actor to attribute their actions to situational requirements, whereas observers tend to attribute the same actions to personal dispositions. So this is like when you're driving down the road and somebody blows by you on the highway, you say, what an idiot. But if you're speeding down the highway, you often have a good reason. You explain it based on the situation as opposed to your own personal disposition. And I think the fundamental attribution error is actually pretty dangerous when it comes to trying to solve problems, because teams end up trying to improve a process. We talk about process improvement, but we end up blaming people. And that's a huge mistake. We have this tendency to focus on the people. The natural way to solve problems is to blame the person. And I think this is largely because of the fundamental attribution error. So the countermeasure for that, or the response for that, should be to go and see, go to where the process occurs, document the current condition. And this is important because even if you focus on the process and seek to blame the process, understanding that most of the time it is the process or the system which is at fault. When we don't document the current condition, we actually then can succumb to some other issues. So my strong encouragement is that we avoid the negative consequences of the fundamental attribution error because we go to where the process is done. We spend time documenting the current condition so that we can ask questions about why the issue exists. And my final brief interlude is a bit of a brain teaser. So I want you to think about this, and once again, no need to try to respond, but I want you to suppose that of the 4 cards on the slide, each has a number on one side and a letter on the other. And somebody tells you if a card has a vowel on one side, then it has an even number on the other side. I want you to think about which of the cards would you need to turn over in order to decide whether the person is lying. So as you think about, and hopefully you jot down, what cards you would turn over. I get this again from the Psychology of Judgment Decision Making from Scott Plouse. This is a really cool study that was done some time ago. And now that you've had a moment to jot down your answer, it's actually interesting because the most common response is E and 4. And in the study referenced, 46% of people responded with E and 4, followed by 33% who responded with E. In other words, most students chose to turn over the cards capable of confirming the statement, whereas only 4% responded with E and 7. So this is interesting because the rule being tested is if a vowel, then an even number, or if X, then Y. The only way to falsify an if-then statement is to find an instance of X and not Y, i.e. a vowel and an odd number. So thus the only cards capable of disconfirming the rule are those with vowels or odd numbers, E and 7. So cards with even numbers or consonants are simply not relevant, but subjects try to confirm this rule more often than disconfirm the rule. So this is a tendency known as confirmation bias, and it refers to a preference for information that is consistent with a hypothesis rather than information which opposes it. So confirmation bias is very dangerous when it comes to problem solving, because very often, even if we answer the question, how will we know if we're better or not with a problem statement? And even if we go and see and document the current condition, we can still succumb to becoming myopic or having tunnel vision because we want to focus on confirming what we think happens in terms of cause and effect. Occam's broom, this is the same Occam as Occam's razor, where the statement is the simplest solution is often the best. But Occam's broom is the process in which inconvenient facts are whisked under the rug. So the reason I bring up confirmation bias in Occam's broom here when we're talking about finding actionable root causes is because we sometimes have a challenge. Kind of the natural way to solve problems is to stop at symptoms or omit finding root causes altogether. And I think this is largely because of confirmation bias. We say, well, here's what we need to do about it. And sometimes teams even think that's what they needed to do before we did any of this A3 stuff. But if we can seek to understand why the issue occurs, not even just the issue, but the waste and variation from the current condition, understanding cause and effect, focusing on the facts, asking why until we get to an actionable root cause. And this is interesting because the word actionable, what I mean by that is we can do something specific to resolve that root cause. And in the Decoding the DNA of the Toyota Production System paper in the Harvard Business Review from Stephen Spear, there's a section referred to as the experiments of the Toyota Production System. In fact, in that issue, it's on page 100 of that issue of the Harvard Business Review. But in the experiments of the Toyota Production System, Spear talks about how organizations use rules. In fact, he articulates 4 rules that can be used to repeatedly conduct experiments. And these rules help us identify issues, the sign of a problem. It actually gives us a hypothesis for how to deal with that and how to respond to that issue. And when we use these rules to help define an actionable root cause, teams are very often successful in developing an experiment to resolve the root cause of the problem. And when I say successful, I mean not just they've eliminated the root cause, but that they have learned how to practice the process of process improvement, because A3 thinking is a practicable skill. And that's really an important part of organizational improvement, is it's a practicable skill. And quite frankly, I don't think anybody can learn how to practice A3 thinking without doing it a few times and screwing it up and reflecting on what the mistake was. What was the deviation from expected? Am I succumbing to biases? Am I using heuristics which prevent me from solving the problem using the scientific method? So the more we can practice this practicable skill of problem solving, the better off I think we'll all be. Which brings me to my last slide before my references, but it is Scott Klaus who says, many of the most effective debiasing techniques involve the consideration of alternative perspectives. And there's a Calvin and Hobbes comic in the book too, but I include it here because I think it's quite fun. But the more we can practice using alternative perspectives to help prevent us from succumbing to these traps, the better we'll be in terms of solving problems as organizations and teams. So with that, Mike, I will actually jump to my references slide in case anybody wants to take a look, but we can now open it up to questions and you can take back.
So we can unmute, I've unmuted the phone, and anyone can ask a question. You can also use the chat function to pose a question to Dan for clarification. So anyone can ask a question by chat. So Dan, one of the things that I've been thinking about is you're encouraging people to get better at practicing and to create, I guess, habits of good problem solving. What have you learned about coaching and advising people on developing good habits around this, or your personal use of good habits?
Yeah, that's a great question. In fact, my immediate response is to get the A3 template, the piece of paper, out for all problems that we want to solve. And I know there's often a response to me saying that says, well, how can we use an A3 for all problems? Because there is this feeling, and it's often from experience, that A3s take a lot of time. And most teams start using A3 thinking to solve problems for things that are fairly complicated or complex. They'll focus their problem solving when it's not easy, quote unquote easy, and use an A3 then. And the result of that is A3s do take time because we're looking at big problems and they often take a lot of effort. Whereas if we would flip that around a little bit and say, well, let's practice using A3 thinking for all problems. Let's start with the smallest problems we can face and get the template out and think to ourselves, how will we know if we're better or not? What is the current condition that leads to this negative outcome? And what is the cause and effect relationship between the process and the outcome that we can apply leverage to try to resolve the root cause, to get better? And if we practice problem solving on smaller problems, we more frequently practice problem solving. And another common response people give me is, well, what if I just do like a PDCA or a PDCA? Instead of an A3, we'll just do like a mini A3. And my response to that is the same. We should just get the A3 template out every time and practice it, because it's when we start stratifying problems into, well, it's a big problem or it's a small problem, and this one's an A3 and this one's not an A3. That's when we stop practicing the principles behind the scientific method being applied to problem solving. So my strong bias is that we use the A3 template, we practice it for smaller problems. It increases the frequency in which we can make mistakes. It increases the frequency in which we can learn from those mistakes. And that increases the frequency in which we learn. And I think that is the most effective way to learn the process of process improvement.
I think that's great advice. I appreciate that. I'm going to give more time here if people have any questions. If you'd use the chat function, we can get those questions without background noise on the phone, which happened previously. So, and maybe this is related to your previous comments, but one of the things I've observed is if you want a sure way to get rid of problems in an organization, introduce the A3, because people will say, oh no, that's too hard. Forget about it. I no longer have problems.
Exactly. Yeah, I think that that's very common too. And I think it comes from the common, and I'll say mistake, I think that might be a little strong, but the common mistake that we only do A3s for certain types of problems. Mm-hmm. And it really, if I go back to how I started talking today, A3 thinking is best practice PDCA. PDCA is just the scientific method applied to process. And I've yet to meet anybody who can argue against using the scientific method to solve problems. Therefore, we should practice it. It's not natural to solve problems using PDCA. I think largely this is because of some of these biases and that we succumb to when we try to solve problems. We say things, I don't have time to measure, we just need to do this. So we jump to solutions, we blame people, we stop at symptoms. Because of all these things, it actually, that is a trigger that we should be practicing using the A3 template. Because the more we can practice using the template, the more we can learn about how it works and how it doesn't work. It's a process of dynamic discovery. And I'll go back to the Steven Spear quote from very early in the presentation. Complex systems cannot be designed, they have to be discovered. Our improvement systems are complex, so we practice it, we screw it up a few times, and then we get better at it.
No, that's great advice. I appreciate that. Well, on the screen, I've turned over to, so what's going to happen next? And Dan's great presentation is going to move over to the recording section. So if you go to our website and look for the webinars, you'll see that it's going to be moving over to the previous events section. So anyone can find the recording there. And I will be sending the recording out to everyone that participated today, and as well as those that are on the distribution list that I've got. We've got another webinar coming up next week. Dirk Van Rossum from Naples, Florida is going to be talking about the application of using quick changeover or the single minute exchange of dies, otherwise using the acronym SMED, for some improvements in OR room turnover. And if you go to the bit.ly link that you see there, you'll be able to get that information as well. Katie Anderson is in November going to be making a presentation on some of her experiences with she's calling it daily intentional practice, but she does some really great work helping people go through good questions to ask as they're trying to solve problems, and trying to apply this personally with daily intentional practice. You can find the details, the dial-up and login, by going to that bit.ly link at the bottom. I'll have more information on the details of what Katie's going to be talking about in November shortly. I've got a number of topics that are in the works that are listed here, and so look forward to that probably in early 2019. Just so everyone is aware, we have updated our white papers. The white papers are all connected to each other, and so part of the update was to make sure that changes or improvements in one white paper led to a coherent link to the other white papers. But if you go to our website and you go to the Foundations tab, you'll see these little boxes here that takes you to the white papers. You can also get there by going to the Publications link. And I just put together a short video. The bit.ly link on the upper right-hand corner will take you to that short video. It's showing some of the changes. The bit.ly links to each of these white papers is shown on the bottom. The one new white paper is one that's been in the process of developing for a number of months, the Pracademics Guide to Strategy Deployment. And so I've gotten a lot of good feedback from that from people. And this is also one of those white papers that I collaborated with a lot of people in making, including Dan from today's webinar. So Dan, thanks again for your input on that white paper. Some other white papers that you can access there. We broke down the principles for aligning, the principles for enabling, and the principles for improvement into 3 white papers, which is an example about why we make white papers. We put them together so that it's something you can learn and read and share with someone. People can probably handle more easily something that's like 10 or 15 pages long, and it doesn't come off as something like a book or anything like that. And so we try to make these accessible and handy. The white papers on the bottom, the practical wisdom for addressing problems. A lot of this has to do with theory of knowledge that Dan touched on today. Evolving worldview has a number of concepts, including how ideas change over time and how we have to continuously learn to stay relevant and to stay up to date. Our recommendations on deploying a principle-based approach is described in the white paper on the lower right-hand corner. And then these 3 white papers here, True North, Side-by-Side Management, and Systems by Design, round out that part of the white paper series. If you go to our publications page, you can see all of the white papers listed here. And I just want to point out there are 4 papers that are available that weren't written necessarily as part of the white paper series, but we've updated them to be a part of this. And so those are listed there. One is performance evaluation. How is this still a thing? Two papers presented at the Deming Research Conference in 2014 and 2015. And then a paper that my son and I wrote back when he was in fifth grade on what do grades mean and the application of quality principles and variation. So Dan talked a lot about variation today. So the understanding about what grades mean and understanding variation, using an example of a red bead factory taught to fourth and fifth graders. So wrap up slide here. If you have a story or lessons that you'd like to share, we're scheduling our webinars out for 2019. You can also join our conversations on the LinkedIn group, and those are always welcome. So again, Dan, thank you for taking the time for this very valuable presentation today. I really appreciate it. And thanks for everyone who participated today. I hope everyone has a good day and a good weekend. Thanks again, Dan.